in single cycle processor, single cycle ISA, we fetch from the very first stage, we fetch instruction. There is PC that tells us which instructions to be executed. Okay, we fetch instructions, we decode it, we perform ALU operation, and then if we required to move in data memory, we move in data memory, and then we will write back. Point and main objective of the pipeline architecture. In the pipeline architecture, we are dealing with multiple cycles, and the very big picture of that cycle is here. This is the very big picture of the pipeline architecture of the RISC-V. Do you see it? This is the book
Yeah.
you have shared with me.
Yes, correct.
Yes. Now, what is the key difference in single cycle and in multiple cycles, which is pipeline variant of the data path? This is the multiple cycle variant of the single cycle. No big difference. Only one difference is that it is a multiple cycle and that is one cycle. Okay.
Yes.
Yeah. Now in this pipeline in multiple cycle in pipeline architecture, we consider clock in every stage. After every stage, when we fetch instructions, we consider clock. After when we go to registers and take data from registers, then we also consider clock. And similarly, when we perform ALU operations, after that we also consider clock. And when we perform operations on data memory, after that we also consider clock. And this is called pipeline architecture, because we are pipelining. Pipeline mean we are reading data from every stage on clock edge. Okay.
Ah, yes. Okay.
Now let me once again tell you in 1 minute. In pipeline, what is pipeline? Pipeline mean you will have registers after every stage. You will have register after every stage. And what is the purpose of that register? The purpose of that register is to store information from the previous stage. For example, here it comes. For example, I will tell you practically. Here you can see if IF and ID.
Mm.
Can you see it?
Yeah, yeah.
IF mean instruction fetch and ID mean instruction decode. Similarly, next stage we have instruction decode and execute register. Similarly, we have execute and memory register. Similarly, we have memory and write back register. Do you see all four registers?
Yes.
So, what is the purpose of first register if instruction fetch, instruction decode? The purpose is that when PC tells us that which instruction will be executed, we fetch that instruction from instruction memory into the register, which is IFID register. Okay.
Yeah,
Okay. We store that instruction into IFID register,
yeah,
and when it is the first clock edge, on the first clock edge we read instruction from instruction memory, and we also read PC value of PC into the register. We are reading two things in the first stage, IFID stage. We are reading two things. One is PC, the second is instruction memory, instructions from instruction memory. All right.
yeah.
All right. Two things we are reading in the first stage. One is instruction from instruction memory, and the second is PC. So this is the first clock edge. So on the very first clock edge, we are reading instruction from instruction memory and value of PC from PC. Okay, you can see from data path. The PC is going here and the PC is going here into the register. This is the value of PC going into the IFID register, and this is the value of the PC going to instruction memory. From instruction memory, we read corresponding instruction into the IFID register. So two things are being read into the IFID register on the very first clock edge. Are you now we have instruction and PC value in IFID register after first clock edge of the cycle of the clock cycle. I mean, after first clock cycle, we have instruction and PC value in IFID register. Now, what comes next? Next, we have to give that instruction from IFID register to registers memory.
Yeah.
Next, first what we did in the first clock cycle, we read instruction from instruction memory and PC value. Okay. Next, what we are doing, we are giving that instruction to registers memory, so we can read register. We are reading the address of first register, reading the address of second register, reading the address of destination registers. Okay.
Yeah.
Okay. When we have read all these registers, when we have read all the addresses from the instruction fetch, instruction decode register into register memory, we will read the data from the register 1 address, and we will read the data from register 2 address. This is same as it were in the single cycle, Isa. Everything is same, everything is same, every operation is same, everything is same. The only thing what is modified here is that we are in single cycle. What we are doing in single cycle we are directly reading everything and everything. Did not have any instruction fetch IFID register, ID EX register, EX MEM register, etc. But in pipeline, we have these registers. Why? Because we are reading data on the clock cycle, on the positive edge of the clock cycle, not randomly reading data or writing data. All right.
Mm-hmm. Okay.
That's why we have brought the concept of pipeline, and we have brought the registers into the stages. After
Okay.
after first stage, now we have read all the values from the addresses of the registers. In the after the first clock cycle, now second clock cycle comes. On the positive edge of the second clock cycle, we will store four things into IDEX register. What those four things will be? The one will be the data from what we have read from the address of the register 1, RS1. Okay.
Yes.
Okay. Okay. The second will be the data what we have read from the address of the register 2. Okay.
Yeah.
The third is the PC value which was coming or which was already coming from the back. Why we are reading PC value? Why we are reading the same PC value again and again? Do you have understanding of this point?
Yes.
Yeah, let me give you overview, because we need in the load instruction and for branch instruction, And for jump instructions, these two to four instructions needs PC value. So that's why we are reading PC value in every stage, so that when
Mm.
we are in need of PC value, we will simply take PC value from that stage and do operations what we need to do. Okay,
Yeah.
that is the concept of PC value, why we are taking PC value in every stage. So in the second clock cycle, second positive edge of the clock cycle, we will read all these four things. Immediate value, we will read immediate value, we will read data 1 and 2, we will read PC value into ID EX register. Okay. Now two clock cycles are done. We are done with the two clock cycles and with the two stages as well. First is the reading instruction memory, and the second is the reading register memory. ठीक है? It's okay.
Yes, sir.
Similarly, we do same things again in the next stage. What we do, we will take whatever value we are required in the next stage, we will take from IDEX register. In single cycle, what we are doing, we were doing read data one from registers into ALU directly. But what in the pipeline is that we have introduced a register which reads value on the positive edge of the clock cycle and gives those values to the next stage.
Yeah.
Now let's move forward. Similarly, now what we will do, we will read PC value. So here one point is extra, that we are reading immediate value to the adder, and we are reading PC value to the adder. This is adder. You can see here it is written add and sum. It is giving out sum after adding immediate generator and PC value. All right.
Yeah.
Okay. So in the next stage, if we are required read data one, what we have read from RS1. If we are require RS1, RS2, immediate value or anything, we will read from IDEX register. Okay. In this stage, the same things are happening now again on but here we are now at, we will now read data on the positive edge of the third clock cycle. We are now at third stage. It means we are at third clock cycle. Okay.
Yeah.
Okay. Third clock cycle. What we when positive edge comes of the third clock cycle, we will read ALU result. We will read zero control signal. It is a control signal. It has the same purpose as it were in the single cycle. We will read some. We will read sum of PC plus PC and immediate generator. Okay, and we will read RS2 again. RS2 directly. uh, ALU result zero and sum. We are reading four things in this register. Values from this stage, when we need values from ALU, but we will not taking directly from ALU because it is not single cycle, it is pipeline. And pipeline means there is all the values we are required in the current stage are being placed already in the register before that stage. So all values we are required now in this stage, where my arrow is moving, whatever we value we are required in this stage, we will take it from EXMEM register. Okay.
Yeah.
Okay. Clock cycle where the register named MEM and write back. MEM memory write back register is introduced. we read values from data memory or from directly from EX MEM register because for this we do not need data memory for in R type we do not need data memory. So in R type we are going directly from this point to the memory write back register. Okay,
Yes.
so we do not need data memory. Okay, for that purpose this arrow is being headed toward MEM and write back register.
Mm-hmm.
So on the positive edge of the fourth clock cycle, we will read data from the data memory if we are required to read data from data memory. Okay, and then we will select one of two values using this mux and write it back to the data register. So now listen. Here you can see 64 and 32.
Yeah.
So 64 and 32 means 64-bit this and 32-bit this. So total it
Yeah.
become 96 bits.
96. Okay.
Similarly, this will be 64-bit.
Yeah.
This will be 64-bit also. This will be 64-bit also. Can you
Yeah.
understand it?
Yeah.
And this is already mentioned that it is 64-bit.
Yeah.
So total, how much it will become? 256 bits.
256 bits. Yeah.
Similarly, this will be 64-bit. This will be 1 bit because this is a control signal. 0 is a control signal. It is 1 bit. You have already learned it in single cycle.
Yeah.
This is
Correct. Yes.
64 bit. It was 64 bit. Now it is also 64 bit. You know this point also. Okay.
Yeah. Yeah.
See, how many bits it will become? 64 plus 64 plus 64. It will become 192. 192 and plus 193 bits. So it is 193 bits of size. This register will be of 193 bits. Okay.
Yeah.
Similarly, this is 64 bit. This is 64 bit.
Yeah.
So total it will become 128 bits. Okay.
Yes.
This is how we calculate the size of these registers. If we are dealing with the 32-bit RISC-V ISA, we will mention 32-bit here, 32-bit here, 32-bit here, 32-bit here, 32-bit here, and we will calculate sizes of these registers accordingly. Okay.
Yeah.
So this was pipeline architecture. These all are basics, but we will move forward with more details.